In this lesson, we're going to talk about radical equations. Everything up to this point has been a radical expression. So now we're going to add that equal sign in. And there is a couple vocabulary terms that we need to know as we kind of progress through this concept. And the first one is called an extraneous solution. And an extraneous solution is a type of solution to an equation like this that emerges from the process of solving the problem, but is not a valid solution to the problem. So I know that's kind of a strange concept, but I'm going to show you how to actually determine if it's extraneous or not. And then the concept of the principal root. So up to this point, we've been talking about square roots and perfect squares. And any time that you have a perfect square value, for example, the square root of 16, we know that it's 4, right? But did you also know that -4 is a root of this square root? And I know that because we know that 4 times 4 gives us 16. But doesn't -4 times -4 also give us 16? It does. So the point I want to make here is that we are only working with the principal root today, which is the positive answer. So we're only looking at 4. We will be looking at that negative root later on down the road, but for today, just focusing on that principal root. So let's look at some equations. Determine the solutions to the radical equation and then check for extraneous solutions. So we always want to solve the problem and then check for extraneous solutions. I'll show you how to do that. So in this first example, you can see that I have an x, and that's my goal. I want to figure out what x is. So I kind of want to treat this as a regular multi-step equation and kind of do the steps that kind of feel right to do. And you might be thinking, well, in this first example, I might want to subtract 6, right? Subtract 6 because it's not underneath that radical sign. So that leaves me with the square root of x plus 2 is equal to 6. Now, here's kind of the new piece. We have a square root here that we need to eliminate. The way that you eliminate a square root is you actually square it, just like this. I'm going to square the square root, but whatever I do to that side, I also have to do to this side as well. So I'm going to do that, and watch what's going to happen. On the left, the square root sign is actually gone, totally gone, and I'm left with 36. I'm going to go ahead and finish up the problem, subtract 2, and that leaves me with x is equal to 34. All right, that is my answer to this problem, but now I need to actually see if this is an extraneous answer, and I'll show you how to do that. I'm going to actually do it over here off to the left-hand side just because I've got a little bit more room over there, but I'm just going to go ahead and plug in x as 34 into the problem. And I'm just going to literally pretend that I'm doing a check step, just like I would normally if I was just doing a regular equation. So this equals the square root of 36 plus 6 equal to 12. And I see that 6 plus 6 is equal to 12. So 12 does equal 12. So what this means, if it actually works in the problem like this and it works really nicely, then this is the answer to the problem, but it is not extraneous. Okay? Now, let me show you what it actually looks like when it is extraneous so you can compare the two. In this next example, you might be thinking, well, to solve this, the first step I actually want to do is divide both sides by -4, right? So here we have -2 equals, and then it looks like I have the square root of a minus 5. To get rid of that square root, I'm just going to go ahead and square everything on both sides to give me 4 equals a minus 5. And I'm going to go ahead, I'll add 5 to both sides. So my a is equal to 9. All right, so that's my solution. Now let's check if it's extraneous. I actually have to write this in. So 8 equals -4 times the square root of 9 minus 5. All right, so I have 8 equals, I have -4. 9 minus 5 is square root of 4, so there we have that. And then 8 equals -4 times 2. Uh-oh. You see what's happening here? Do you see how these two answers, they don't equal each other? This is not equal. So what that means is, yes, a equals 9 is a solution to this equation, but we like to call these types of solutions extraneous solutions. So I would just put a little ES next to it to indicate that this is an extraneous type of solution to the problem. Hopefully that makes sense. I've got 2 more problems for you to take a look at. So let's go ahead and determine the solution, and let's see if they're extraneous or not. So in this first one, hopefully you're probably thinking, well, I want to get rid of the -2 first, so I'm going to go ahead and add 2 to both sides. Treat it like a multi-step equation. So I have -5 is equal to the square root of x minus 1. And of course, I'm going to square both sides to get rid of that radical. So I have 25 is equal to x minus 1. Just go ahead and add 1 to both sides. So I have x is equal to 26. All right, there's my solution. Now let's just go see if it's extraneous or not. So I'm just going to say, I'll put it down here, -7 equals -2 plus the square root of 26 minus 1. And I'm just going to do some simple arithmetic here just to kind of see if it is or not. -7 equals -2 plus 5. Uh-oh, you see what's happening here? -7 is not equal to 3. Definitely not. So this is a solution, it's just a special type of solution. It's called extraneous. And the last one here, let me show you how this one works. This is kind of a different one. Notice how we have radicals on both sides of the equal sign. It's different from all the others that we've done. In this case, you can immediately go straight here and start getting rid of those radicals. That'll leave me with 2m equals 3m minus 2. And then, of course, you can just simplify it from there. So I'm going to go ahead and subtract 3m from both sides. Oops. See my pen's working. There we go. -m equals -2. Divide both sides by -1. So m will equal to 2. So there's my solution. Let's just go ahead and double check to make sure that it is or is not extraneous. So I've got 2 times 2, square root of that, and then 3 times 2 minus 2. And I'm just going to go ahead and simplify that down. I've got 4. I've got 6 minus 2. Let's see. Looks like it's good to go. 2 is equal to 2. This is actually a real solution. I'm just going to leave it just as is. Okay, so that brings us to the end of our lesson on radical equations. Now you might be wondering, well, when will I actually use these radical equations? And that's going to be in the next lesson on the Pythagorean theorem.